So we talked about the front page in class, so I'm just gonna jump to the back of the back of the first page. Okay. From the top of a 45-meter cliff, a group of soldiers fire a cannon horizontally with an initial velocity of 120. So this is a horizontal projectile. So that means when I make my chart, obviously I have how high this cliff is. So that's going to be 45 meters. Because it is going down 45 meters in the y direction, I'm going to make that a negative. This is a horizontal velocity, so an x velocity of 120. I can always put my acceleration, and because this is a horizontal projectile, I am starting at the top. I know my y velocity is 0. That's at the beginning, because the top is at the beginning here, so that should be VI, not VF. I want to look for how far away the cannonball lands. That is looking for x distance. First things first, I need to find time. I have y distance, acceleration, VI, so that means I can plug into my equation. And now, make sure I only plug in y values, don't mix and match. So the y distance is negative 45, 0t, 1/2 negative 9.8 t squared. This is going to be 1/2 of negative 9.8 is negative 4.9. And then I have negative 4.9 t squared, trying to get t by itself. So first I would divide the negative 4.9 over. Negative 4.9, or 45 over negative 4.9 gives me positive 9.18. That's what t squared is, right? Still not done for t, so I need to undo the square, so take the square root, so that gives me my time is 3.02. Now, not my answer, but that's the first thing I need to do. I'm looking for x distance. Anytime you're looking for either x distance or x velocity, you use your x equation, which is v equals d over t. I want to use my x velocity, 120, looking for x distance, and I'm using my time, 3.02. So because I want to get d by itself, I'm going to multiply the 3.02 up, and that gives me an x distance of 363 meters. There's some decimals, but I just left it off. If the cannon shot with a faster velocity, so let's think about if I go up here and I shot this with a faster velocity, how would that affect the time it takes for the cannonball to reach the ground? Well, when we're talking about time, only the y component matters. Here, that velocity was an x velocity, so going faster in the x direction is actually not going to affect the time at all. So I'm going to say no effect. It would be the same time if it was a faster velocity or if it was a slower velocity. Or if I just dropped it with no x velocity at all, it would be the same time because it's the same y distance. If it was shot with a faster velocity, how would that affect the horizontal distance it travels? Well, it would be in the air for the same amount of time, but now it would be going faster, so of course the faster one is going to go farther, so it would be a farther distance. Because yes, the time is the same, but now I'm going faster, so that means I will go farther. So farther distance, you can say it lands farther away. Number 4, a projectile is launched at an angle. I want to label the range and the peak height. So range is the x distance, like this. So you need to just recognize that range is x distance. Peak height is like your max height. That is this distance, peak / max height. And then lastly, we're drawing the arrows that represent the acceleration. Well, at every single point, your acceleration is just gravity. So gravity, these are all represent the acceleration at each of the points, and they would all be the same length because your acceleration is just negative 9.8 at all of the points, and that is pointing down. That is for when it asks for the direction of the acceleration. Now I'm asking you horizontal and vertical velocities at each point. So let's start with some Vx and Vy. X is easy because I know x is actually going to be the same at every single point. So Vx is going to stay the same because x velocity is constant. Vx is constant. My y velocity is not going to stay the same. Think about when I throw something up, yes, it just starts moving up. It doesn't continue moving up. It gets slower until your y velocity is 0 at the top. And then after the top, now it starts to move down. And as it's moving down, it gets faster. And just a note, this velocity and this velocity would be the same. This velocity and this velocity would be equal, just opposite directions. It's totally symmetrical until you get to 0 in the middle. If the initial velocity in the above diagram was 14 at an angle of 40 degrees, I want to fill in my chart. So first, let's find the initial vertical and horizontal velocities, like at point 1. So Vix would be 14 cosine, that doesn't look like words, 14 cosine of 40. 14 cosine of 40 is just 10.72. VIY would be 14 sine of 40. Put that in your calculator. You get like 8.999. I just made it 9. So that's what it would round up to. So this one, x is talking about horizontal velocity. So my horizontal velocity at the beginning is just my initial x velocity, 10.72. My vertical velocity at point 1 is just my initial vertical velocity, which would be 9. Now, horizontal velocity, I'm going to make a note, that's x. My x velocity is constant. It does not change. So this is going to be 10.72. At literally any single point, I know my x velocity. My vertical velocity will change, right? It's constantly changing because I have an acceleration in the y direction. So what I know is it goes up with 9. The next point I'm axing at is 2. Well, 2 is easy. You can actually know my y velocity at the top. It's 0 because I'm at the top. And then at 3, well, I'm back at the same height that I started. So now I have the same velocity. It's just down. So I'm going to say that's negative 9. My vertical, again, vertical is talking about y. My acceleration in the y direction is negative 9.8 for all points. Doesn't matter what's happening. My horizontal acceleration is none or 0 for all points, right? The only force acting on it is gravity, so my only acceleration is gravity. There's no sideways acceleration, which is why the sideways velocity, horizontal velocity, is constant. What do we know about the projectile's total initial velocity and the total velocity when it returns to that height? So think about the total initial velocity here was 14. So if something goes up with 14 meters per second, what do we know about the velocity when it returns to that height? Hopefully you're thinking, it's the same, it's 14. So yes, it is the same. Technically the y part is now down. It's right and up here where it's right and down here, but it's still the same number. It's the same speed. A table or a ball rolls off a table at 8 meters per second. Another one rolls off the table at 16 meters per second. Which one hits the ground first? Well, we already set up here that going faster in the x direction isn't going to matter because when we're talking about time, all we care about is y. As long as it's the same table, it should be the same height, so this would be the same time. What if the ball weighs 3 times more? Well, we know that mass isn't going to affect how long it takes to fall down, so still the same. The only thing that would affect the time is the y distance, so if I went from a higher height or a lower height, or if I gave it an initial velocity in the up or down direction. 2 projectiles launched at the same velocity, one at an angle of 25, one at an angle of 65, so it's helpful to kind of picture this. So 25 is a small angle, whereas 65 is like a big angle, more upward angle, but it's still the same velocity, it's just at a different angle. So which one has a greater velocity at the top of its path? So just any generic one, we know at the top that your y velocity is 0, but I still have x, so you still have x velocity. So the one that has the greater velocity at the top of the path, well, their y's go to 0, they only have x, so it's just the one with the greater vx. So x is the sideways part of the motion, so we just look, and it's constant, so whoever has the greatest vx at the beginning, while the one that has the greatest vx is the one that's going more in the x direction. This one has the greatest y initial velocity, which is not what I'm thinking of right now. So then this would be, the answer would be the 25 degree one. This is the 25, and this is the 65, by the way. Which one's in the air for a longer time? So this, we just care about the y, who has the greater y, because I want more time. Looking at these, the one that has the greater initial y velocity is the 65, because it is putting a lot of its velocity upwards, not as much x, which is why this one had a greater x, not y. Higher maximum height is the one that is, again, more y, so still 65. Max height or more height and more time will always go together because they go with y. Greater acceleration should be the same. They both have an acceleration of negative 9.8. A baseball player throws a pitch horizontally, so we're talking about a horizontal projectile like this. and that has a speed or velocity of 50 meters per second. It reaches the home plate 15 meters away, so that is the X distance, not the Y distance. Also looking for how far the ball has fallen vertically, so that means I'm looking for the Y distance. And then of course I can always put my acceleration in my chart, and because this is a horizontal velocity, it is VI that is 0, not VF. The initial velocity is 0 like this. We always find our time first, so I don't have enough to use a Y equation, but I have V and D for X, and my X equation is just V equals D over T. V is 50, distance is 15, and I'm looking for time. Now this one I have to be careful rearranging this because my time or my unknown is on the bottom. So before I can move the 15 or the 50 over, I need to move the T up. So I'm going to multiply both sides by T. Now I have T over T, which cancels out, so this is just 50T equals 15. To get T by itself, I'm going to divide the 50 over like this, and that gives me a time of 0.3 seconds. And then now that I have my time, now I'm ready to find dy. Y distance, I want to use d equals VIT plus 1/2 AT squared. VI for y is 0, that goes away. 1/2 negative 9.8 t 0.3 squared. That gives me a y distance of negative 0.441 meters. And the negative just means that it's going down that far. Oops, I didn't see that. It's going down that many meters. 11, a ball is thrown at 53 meters per second at an angle of 34. Find the maximum height and the range. The maximum height is the y distance. Range is just the x distance. This is an angled projectile, so the first thing I need to do is I need to do VIX is 53 cosine of 34. That gives me an x velocity of 43.94. I need to do that VIY is 53 sine of 34. That gives me an initial y velocity of 29.64. I can always put negative 9.8 for my acceleration, because we are talking about something in the air. Gravity is accelerating it. And then I have an initial velocity. Your y velocity is 0 at the top. That's not at the beginning because I'm pointing up, right? That's going to be later on. So I'm going to say that VF is 0.